Everyone, welcome to this second part of the video for the white light lesson, lesson 15 in the Sound of Light scheme of work. This part is a bit of an optional explanation that you can do. This is around Newton's idea that light is made up of these various different components. And again, just to emphasize, not every student needs to know this, so do be judicious about whether you choose to go through this or not. But certainly, if you've got students who really want to find out more about science, I think this is a good thing to talk about. So the first diagram that we drew in the previous video that I made on this lesson was something like this. Now, Newton's, or the way this had been explained, I beg your pardon, before Newton's time, was that the reason this happened must be to do with impurities that you have in the glass. So the reason when you shine this perfect white light from a flame or a bulb or whatever it might be, not that they had bulbs in Newton's day, but whenever you shine this white light at a prism, the reason you get this splitting is because light is essentially interacting with the glass and causing this random scattering, it's kind of messing up the signal that's incoming. So you get this kind of weird colourful effect. But no one really thought it was anything kind of too serious that scientists needed to pay attention to. Now, if that was true, let's say that's our guess, and I could lay this out as follows. So I might do this for students. So if the guess is that, well, when light comes into the prism, let's sketch the prism here. If the guess is that this is caused by random scattering effects, well, let's draw it like this for now. But really, there's no particular reason that it should always happen in that sort of order. Actually, the colours could all be mixed up. So you could get, another time, you could get some kind of green light coming out here, like that, maybe even coming out here, whatever. All sorts of light could be coming out. And scientists didn't really look that closely at the colours that were coming out. They just said, oh, you get a lovely pattern, but it's probably just caused by random impurities in the glass. Now, if that was true, remember, this is recapping this idea that scientists they make guesses about what's going to happen, and then they ask themselves, well, what would we expect to happen if that was true? Well, if that was true, let's imagine now, this is what Newton thought, let's imagine you had two prisms that looked like this. So if you shone light at one of them, like this, white light, and it split in all sorts of random directions, I'm just going to exaggerate here, but something like this, whatever. That. Well, what you would get, if I move this down, what you would get after the light has passed through the second prism is another fairly random pattern. You might get even more colours, who knows? But we can kind of draw it looking like this. Whatever, some sort of random pattern. The reason being, this is just caused by more impurities. So these different rays of light that have emerged from the first prism, well, they're just going to bounce off more stuff inside the glass, and who knows what's going to happen. Now, what Newton did was say, well, actually, I don't think this is correct. I actually think something else is going on. So let's draw what Newton thought. And I would sketch this out to students as well if I thought they were the kind of group that was going to get something out of this. So if I sketch this, and the first thing that Newton thought was, oh, I should do green next, that actually this would be a predictable pattern, that you would always get the same colours in the same kind of relative position within the rainbow. So you'd always get red at the top at one end, the blues and indigos and violets at the other end. A good fact that a former colleague once mentioned to me was that actually, really you can only see 6 colours. The reason we say it's 7 colours is because Newton notoriously was extremely superstitious, and 7 was thought to be this kind of mystical number in the universe, based on his kind of religious beliefs and non-scientific beliefs, let's say. So he thought, there can't just be 6 colours, there must be 7. So he kind of invented this indigo violet distinction, which no one really can see. That it's just purple, and so it's one you can tell your students if they're struggling to distinguish between indigo and violet. Well, that's because it was a bit of an arbitrary construct by Newton. But anyway, what he thought was you would always get the same relative positions within the colour of the rainbow. He thought this was a predictable phenomenon, and what he deduced from that was to say the following: that if this was predictable, and they always, red always refracted by a certain amount, and blue and green and so on, well then, if you were to do this, let's sketch again, a bit like we did above. If you were to do this at a prism, and then shine it through the second prism, shine the light that was produced through the second prism, as follows. Try and do what he expected to happen, do the green next. These shouldn't quite be parallel actually, so they should look something like that. What you would expect to happen is that actually these 3 rays of different coloured light should, if you've positioned the prisms correctly, they should come back together to form white light. So white light in leads to not some even more random effects as would be predicted if the refraction was caused by impurities in the glass. He expected, well, you should probably get white light out. And you can guess what is actually observed if you set this up properly. Not that I've ever done it. I'm taking Newton on his word here. But what you actually get is not that. You don't get that. What Newton actually observed was that he got the white light back again, which is showing, and this is the really important point that I stressed in the first part of, or the first video for this lesson, in the first part of this exposition. What students need to understand is that these 2 things are exactly the same. So it's not that there's white light and then there's a rainbow, which is something different. Those colours of the rainbow that we talked about over there, they are, when they're combined together, they produce white light. So they are white light. And this is what Newton's experiment shows really vividly, is that yes, you can split white light apart into its constituent components. You can also then bring those components back together and you will get white light again. And this is a nice example. Sorry, I should have added the final stage of how science develops here, the check. But this is a nice example of how we can use our deductions or use experiment to check our deductions to work out whether or not a model is true. And in this case, this idea that it was caused by impurities in the glass was not true. It was actually something fundamental about white light itself. And this was Newton's great insight during his own experience of lockdown. So that was a bit of an optional extra for those students who really need to be pushed and stretched a bit further. And you'll find 2 sets of questions depending on whether you went into this exposition in these slides. I hope that was useful. Next time we will look in a bit more detail at colours.